أجمعين. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. اللهم لا سهل إلا ما جعلته سهلا وأنت تجعل الحزن إذا شئت سهلا. Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. Can you see the screen, the slide?
Yes, doctor.
Okay. Wait. Okay, give me a few minutes. There's some technical error here. Give me a few minutes. Okay, right. Okay, Bismillah. So how was your test actually? Testing.
Alhamdulillah, doctor. It was good.
Oh, okay. Okay, only Hussein good. How about others?
Easy.
Huh? Easy? Easy, right?
Yes, doctor. Thank you.
Okay. So I think you can score 100% for the test one. Is it? Can you
Yes,
solve?
doctor. Inshallah.
Okay. Inshallah,
إن
inshallah.
شاء الله دكتور.
Good. Wong King Tong say cannot solve last question. Okay. Alright, never mind. I will explain why I put question 4 later on after I mark your test 1. So once the mark is ready, I will pass to you, and then I will explain why I put question number 4. Right. Let me check. Okay, all right. So let's start with the lecture. Okay, just want to know what you have learned from the previous lecture. Okay, so maybe before we start the new topic, I just want to know what have you learned from the previous lesson, from the previous lecture. Okay, so actually what you have learned.
The 2D and 3D equilibrium.
Okay, all right. Any more?
Moment of particles.
Okay. Any more? Any more? Any more? What you have learned, guys?
3D moment, and we take some examples. We solved some examples.
Difference
Okay.
between a particle and a rigid body.
Okay, great. Any more?
Equilibrium and resultant.
Okay, great. How about principle? What principle that you have learned? Florence. Oh, Florence and Jade Win.
Yes, sir.
I never heard your name before.
Yes, sir.
Are you new student?
No.
Oh, okay. Did you put your information in the Padlet?
Yes, sir.
Oh, all right. Okay. Any more that you have learned? What kind of principle that you already know? Okay, there is some comment in the chat box. Moment in 2D, equilibrium, principle of transmissibility, physical independence. Yes. Kenapa tak nak cakap? Okay, so basically, yes, of course, you have learned particles, very basic body actually. Okay, particles, dot one. Okay, in particle, you learn about 2D resultant and equilibrium, 3D resultant and equilibrium. Okay, and then we enter to the rigid bodies. Okay, after this, in the next semester, next semester, I believe that in year 3. Semester 2, okay, for normal intake, you will learn about solid mechanics. Okay, you will learn about solid mechanics. So what you have learned in the static is about particles in rigid body, but in a solid mechanic, you will learn about deformable body. Okay, and this is the thing that you will learn later on. Okay, we do have 3 lah. This is number 3. Okay, number 1 particles, number 2 rigid bodies. In rigid body, you learn moment 2D, you learn moment 3D. Okay, and then in solid mechanics, you will learn deformable body, deformable bodies. Okay, so all right, this new lecture, it is still a rigid body. It is still rigid body, but we extend the moment actually. So last week you have learned about moment, but this time around you will also learn moment, but involving two different kind of forces with a same magnitude but different direction. Okay, and that one we call it couples. Okay, what you will learn for today is the number one is concept of couples. What is couples? What kind of situation if we have a number of forces? Okay, what kind of situation that we can consider as couples? Okay, and then you will learn on 2D couples, yes, and 3D couples. 2D, of course, we do have to exist only. 3D, 3 axis, okay, with different plane. Okay, 2D only one single plane. 3D we have different plane. Okay, and number 4 is example and exercise. Okay, so this is the concept of couples. Okay. In a simple terms, couple is pair of force, two forces that have same magnitude, opposite direction, or parallel line of action. Okay, if you found a pair of force, okay, two forces that have these criteria, same magnitude, opposite direction, parallel line of action, then we can consider that system is in couple. Okay, so for example, like this. Okay, for example, like this. So we have x and y axis. Okay, and we have this forces, for example, like this. Okay, if you have two forces that have a same magnitude, let's say I put it 10 Newton here, 10 Newton here, okay, opposite direction to each other, the upper one going to right, the below one going to left, which is opposite direction, and parallel, okay, both of them are parallel, meaning is that this is the system that having couples, okay, the system having couples. So let's say we do have these forces, okay, one is like this, say put it 20 Newton, okay, and another one like this, 20 Newton. Is this considered as couple?
No.
Okay, great, very simple, right? Okay, very simple. Okay, so this is an example for 2D couples. The concept of 2D couple is illustrated by the following example. Okay, we do have a rigid body there. Okay, rigid body from A to D, A, B, C, D, rigid body. Have two different forces, but have same magnitude, different direction in parallel. Okay, in parallel. So if you found this kind of system, okay, so this is couple. All right, why we learn couple? Okay, later on, if you go through a lot of example, you will know why we learn couple. Basically, what I want to tell to you, the couple, the use of couple is actually you can calculate moment about any point, okay, about any point that you like, because the calculation, the final answer will be same, okay, will be same. Okay, let's say you want to calculate a moment in about point A lah, for example. Okay, then you calculate using the formula, you will get the answer like shown here. Okay, 400 Newton meter. Okay, let's say you want to calculate moment about point B. Okay, you calculate using a normal equation, normal formula, you will get the same answer as well. Oops. And then you calculate a moment about point C, you will get same answer. and then last one, moment about point B, you will get the same answer. Okay, so the thing that we learn about couple is just want to show you, okay, any point that you calculate for moment, the answer will be same if the system having couple. If the system having two forces that have different direction, same magnitude, but in parallel, okay, and parallel position, okay, right? So if you want to try, you can try now to calculate a moment. Okay, you can calculate here, for example, a moment about this point A. Okay, if you choose point A, you will only consider this force in your calculation. Okay, this force in calculation. Okay, let's say I put it counterclockwise. Clockwise is positive. Okay, so it will be equal to 100. Distance is 4, equal to 400 Newton meter. Okay, so this one we're not considering if you choose point A. Okay, so far any question?
Why for MB we added, but MD we subtracted?
Okay, you cannot simplify, put sign positive or negative like that. You have to understand on how to get the answer, on how to get the solution. Okay, never mind, I can explain to you. It is all. Okay, it is all. Okay, let's say you want to calculate a moment about point B. Okay, we go one by one. Okay, a moment about point B. Okay, we take this point. Okay, and we have to, yeah, of course, we have to simplify the equation. We have to assume the first direction. I assume the positive one should be clockwise. Okay, like this. Okay, so if any that follow this assumption will be in positive direction. Okay, we do have the first one, which is this force. Okay, 100 times 1. Okay, and then plus another force, which is here, 100, distance is 3, and we will get the answer. Okay, so if you go to C, we only consider one force because the C point having another force 100 Newton. So there is no distance at all. So we can consider the moment for this force is equal to 0. So for point C, again, assumption positive should be clockwise, equal to 100 times with distance. Okay, you will get 400 Newton meter as well. Okay, straightforward. And how about MD? The one that you asked just now, MD. Okay, this is the point that you take for a moment. Okay, all right. So you have to assume first MD, let's say positive is clockwise. Okay, so equal to the first force is this one, 100. Since the 100 is following the assumption, it should be positive lah. The direction is this one, 1 plus 3 plus 2. So we have 6. Okay. All right. So the second force is this one. So if we push this rigid body to this direction, and the fixed one is the point. So you will know, you will imagine that this rigid body is having like this way, is counterclockwise. So that's why we get negative 100. Okay, and the distance should be 2 lah. So you will get 400 Newton as well. Okay, so basically positive and negative should be from the assumption and also from the rotation of rigid body. Okay, so the first force is like this, point upward. Okay, and we fix at D, we can imagine that this rigid body will be turning, will be rotate in clockwise direction. But the second force is a downward like this. Okay, we fix at D. If we push the rigid body downward, the rigid body will be rotating anti-clockwise. Okay, am I answering your question?
Yes, doctor. Yes. Thank you.
Okay, great. So is there any more question before I proceed? Asan, did I answering your question?
Yes, doctor. Understood. Thank you.
Why? Okay. So any more question before I proceed? Respond, please.
No, doctor.
Okay. Okay. So another couples. Another couples. There is another information that you have to know about couples. Okay. A couple, it is not a relationship between man and woman. It is a relationship between force and force. Okay, in this static lah, of course. So couples, the first point that you have to know is about the independent. Okay, so moment produced by a couple is independent of the point the moment is taken. Do you understand what is the meaning of this sentence? Yeah.
No, doctor.
No. Tadi example, the previous example already show you. The moment produced by a couple is independent of the moment, the point that the moment is taken. The moment produced by a couple is independent of the point the moment is taken. The moment produced by a couple is independent of the point the moment is taken.
No matter whichever point we take on the body, the torque or the moment will be same for all conditions.
Yes, correct. So no matter how, no matter where you choose the point, okay, the moment will be same forever and ever. Okay, it is not dependent on any other in any points lah. So the meaning of independent there. Okay, independent. Oops. Yeah. Yeah, independent. Okay, moment is not depend on any point. If you have a couple lah. Okay, if you have a couple, it is independent. So no matter how, no matter where you choose the point A, B, C, D, the moment will be same forever and ever. Okay, so this is the meaning of the first statement. Okay, so the number two, the moment of a couple is a free vector, i.e. the moment can be placed anywhere on the rigid body. So do you understand what is the meaning of this statement? Anyone? Anyone? Come on, guys. Tak sarap lagi eh? Ke tak sahur? Anyone?
It's similar to the principle of transmissibility.
No. 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 Anyone? No idea. Okay, so the meaning of this statement is actually, okay, the moment that you calculate just now, let's say 400 Newton meter, can be placed anywhere on the rigid body. Okay, 400 Newton meter can be placed any point that you like. Okay, if it is free vector, it's not only the point. Okay, let me erase this one first. Erase. Okay, so any point that you like, let's say you got 400 Newton meter lah, and the direction is this one. Okay, so you can place this. Okay, you can place this moment. Okay, because the moment of couple is free vector. Free vector. Okay, free. You can put anywhere. Okay, you can put here, for example, positive. Okay, you can put D. You can put here. You can put here. Okay, and the important thing that not only on the point, you also can put along the rigid body that you like. For example, you put here. You put here. You put here. Okay, so any point that you like, because the moment will be seen along the body, along the rigid body. Okay, so this is the meaning of the second statement. The moment of a couple is free vector. It is free vector, where the moment can be placed anywhere on the rigid body. Okay, so number 3, magnitude of the moment of the couple equals the force times the perpendicular distance between the line of action of the two forces. As you know that we do have this equation, m equal to fd. Okay, the magnitude of the moment of a couple is actually follow oblique this equation. Okay, and then number 4, two couples are the same if the resulting moment are equal magnitude and direction, and both couples are on the same or parallel planes. Okay, so the last statement, do you understand?
Yes, doctor.
Okay, can you explain to everyone? Who said yes just now? Rabiul. Rabiul Hassan, did you say
Yes,
yes?
doctor.
Can you explain your understanding on that statement?
No, doctor. Sorry.
Ah, father-in-law.
I understand, but I cannot explain.
Okay, all right.
Doctor,
Sorry.
can I try?
Yeah.
These two couples can be imagined as similar as two vectors in a plane which have same magnitude and direction.
Can
So
you repeat?
in a plane, if we have two vectors that are parallel and magnitude and direction are equal. So in this case, we have two couples, which means 4 total forces. So the total of any two, is equal to the total of the other two. Thing like that.
The total what? Total moment, total force?
Yeah, resulting moment.
Okay, great. Okay, thank you. Who just said just now? Hassan.
Yeah.
Hassan. Okay, great. Okay, correct. So when you have 4 forces in a plane, okay, and from the 4 forces, there are two couples. Which is 2 pairs. Okay, so from the 4 forces, 2 couples are the same. Okay, 2 couples are the same in terms of magnitude and direction if the resultant moment are equal. Okay, if the resultant moment are equal. Okay, let's say yeah, of course in 2D we have difficulty to imagine, but I try my best to explain to you in a figure like this. Okay, let's say we have this force F and F, and another one like this. I put it P lah. Okay, if you found this kind of system having 4 different forces, okay, but we can see that there are 2 couples there. Okay, you can apply the fourth statement where 2 couples are the same. Okay, the same meaning that the moment, the resultant moment is equal in direction, both direction and magnitude. So let's say you put yeah, a moment about this point lah, for example. It is difficult to draw like this. Let me draw in rigid body. Yeah. Okay, let's say you have this a rigid body lah, for example. A simple rigid body like this, and another rigid body, maybe different, same shape but different orientation, maybe like this. Okay, so you have force, you have this force. Okay, so another force maybe in terms of P and this P. Okay, so if you have this system, 2 different rigid body with 4 forces, okay, 4 forces, okay, you will find that 2 couples, which is the 2 couples having moment, okay, are same, okay. So moment about this point, for example, moment about this point B, and we do have a point Z lah, for example, moment about point Z, okay, will be same. These 2 will be same. Okay, the 2 couples are the same if the resultant moment are equal. Okay, so let's proceed to the next one. Concept of equivalent couples. Concept of equivalent couples 2D. Okay, you can transform the forces into different direction, into different magnitude. Okay, you can transform like this. Okay, let's say the original is here. Let's say you want to solve a problem that don't want to have this kind of direction. Let's say you can transform this direction into this one. Okay, all right, how to transform? The first thing that you have to know, the first thing that you have to calculate is moment lah, of course. Moment, any point that you like. Let's say I put it moment C lah, the easiest one. Okay, you will get straight away negative 90 times with 3. Okay, negative how much 270 Newton meter. Okay, point C. Okay, so you will have this moment, you will have this moment 270 Newton meter. Okay, so once you have this, moment, then you can transform the forces into different direction as shown in here. Okay, how to transform? Any idea? Anyone? How to transform? Someone? How to transform? Someone? Yeah. Anyone? Anyone? Hey, come on, guys.
One condition is sure that we should get a resultant as 270 Newton.
Get the resultant.
Point C, if we change the force, we should still get 270. That is one condition, I think.
Oops. Again.
I'm not sure was, but at the point C, when we change the force, we should still get the resultant as 270 Newton.
The resultant or the moment?
The moment, sorry. No.
Yeah, correct. Yes. So the moment will be same, but the direction will be different. Okay. And also the magnitude. If you change the direction like this in the blue arrow, okay, this system having same moment actually. Okay. You can find the forces using this moment. Okay. You can find these forces. Let's say I put it F. Okay, you can find the F value using this moment. Okay, let's say I use the same point which is which is C. Okay, you can do like this. I assume positive is clockwise. Okay, so in this situation we do have negative F and distance is 3, and the answer is a negative 270. Okay, 270. You will get straight away. Okay, how much? This one.
Again, 90. Same. Negative 90.
Oh, sorry. Sorry. This one is a mistake. It should be 270. Right. 360. This one should be 360. Am I right? Can someone check? Right. Can someone check for me? Guys?
We take the distance between B and C, then it should be 360.
Okay, great. So the answer for this one should be...
So normally which distance should we take? Like 3 meter or 4 meter at point C?
Hey, this moment. Wait, let me explain. Okay. All right. So the first thing that I calculate is wrong. Basically, if you want to calculate moment about any point A, B, C for the first rigid body here, okay, you will get 360 Newton. Right. Do you get the same answer? Guys, do you get the same answer? Respond, please.
Yes, yes, doctor, yes.
Okay, great. So if you want to translate the force, okay, if you want to translate the force like this position, like this direction, okay, like this direction. One is downward, another one is upward. Okay, you can make it like this, but the force will be different. Okay, the moment will be same, okay, 360, but the force in terms of direction and the magnitude will be different. So you can use this moment 360 from the beginning, okay, to get F. To get F using this formula, the simple formula M equal to FD. Okay, so if you take a moment about point C here, okay, you will only consider this force to get the solution. Okay, so the distance from here to here is 3. Okay, okay, from point to the line of action force here is 3. Okay, so I assume clockwise is positive. Okay, and this system having negative F time with the distance 3 equal to negative 360, because negative 360 is anti-clockwise, that opposed to my assumption there. So both are negative. The final answer of F is equal to 120 Newton. Sorry, not Newton meter. Let me erase this one. Should be Newton only. Okay, should be Newton only. Okay, so you can put this 120 Newton and this 120 Newton as well. Okay, as similar as this one, as similar like this one. Okay, so the question from your from Hussein, from Hussein, right? You asked me, right? So for this case, the distance is this one, D.
No, doctor, I didn't ask.
Not you. Okay, okay. So for this one, the distance is this one, D. Okay, this line of action. Oops. This line of action, okay, we're not considering these forces, we're not considering these forces because we are taking moment about this point. Okay, we only consider the upper one. Okay, so D is the D between the line of action and the point. So D is a D, 4. So straightforward, negative 4, you will get this answer. Okay, all right, do you clear, guys?
Yes, doctor. Yes.
Okay, so what I want to try to explain is actually the concept of equivalent couples, the concept of equivalent couples in 2D. With having the same rigid body with dimension 4, 3 for all rigid body in the system, okay, same point A, B, C there, okay, you can transform, you can translate, you can convert, okay, this force into different magnitude and direction like this one, okay, and maybe you want to make it like this one, or maybe you just want to have this one only, or maybe you want to have this one only. Okay, all right. Okay, guys. So another thing that I want to show is the concept or the arrow to illustrate the moment. Okay, the first one is this one, the second one is this one. Okay, you can illustrate this kind of arrow to show the moment direction. Okay, so this arrow, you can put any point that you like, as we discussed the previous one, which is this one. Where is it? Where is it? Yeah, this one. Okay. Okay, you can put any point that you like because the moment will be same if you have a couple system. Okay, and this example only put it at C point. Okay, C point there. Okay, another type of illustration of moment. Okay, like this arrow, like this arrow, yeah. Okay, this one if the rigid body having anti-clockwise direction. So if the body having clockwise direction, it should be like this lah. The direction, the illustration of direction should be like this. Right? Sorry. It should be like this. Okay. Or it should be like this, of course. If the rigid body is clockwise direction. Okay. All right. Any questions so far? Any question? Guys, any question?
No, doctor.
Okay, if no question, let me proceed to the next one. Okay, so if you have two moments, okay, two moments in a rigid body like shown in the slide right now, okay, you can simplify that moment. You can simplify that moment. Let's say you have this system having two different moments on the rigid body. Okay, the first one is 20 Newton meter in anti-clockwise direction, counterclockwise direction, and another one is 60 Newton meter also in counterclockwise direction. Okay, you can do addition and subtraction. Okay, you can do addition and subtraction. Okay, you can just simplify between just simplify this moment. Okay, in this case, the same direction, which is both are counterclockwise, you can add this value 20 plus 60, you will have this one. Okay, so the point that you take, it is independent. You can put at B, you can put at C, you can put at A, because this one is coupled. Okay, in this illustration, in this example, okay, we put it at point B. Okay, the 18 Newton meter can be put in A or C or D or B, sorry, or B, any point. Okay, so the second example is here. Okay, different direction. The first one is anti-clockwise, which is 20 Newton meter. The second one is the 60 Newton meter, but in clockwise direction. Okay, so let's say you want to have this direction. Okay, you can add or subtract like this. Okay, 20 minus 60 lah. So you will get minus 40. Or maybe you don't want to have this direction, you want to have this direction of clockwise. Okay, you can have minus 20 plus 60. So you will get 40 Newton meter. Okay, do you get, guys? Easy, right?
Yes, doctor.
Okay, so if no question, let's proceed to the 3D couples. Okay, it is same like 2D, but of course 3D a bit tricky there, where we have to have a lot of imagination. Okay, so if you can see this slide, we do have two forces. this one, and this one, okay, with same magnitude of F, different direction. One goes to the negative Z direction. One goes to positive Z direction. Okay. And parallel. Parallel means that the plane should be same lah. This is the plane for the force. Okay. Let's say the force is acting like this. Okay, and the force is acting like this. Okay. All right. So we can consider also a couple but different plane. Okay, the plane maybe should be like this lah. Okay. Okay, for this case, we assume ni the simple plane, which is the plane is here. The plane. And the force is acting on this plane with different direction, same magnitude. Okay. All right. If you found this one, you have to consider this system is in couple system. Okay, is in couple system. So if you have this system, of course you can calculate moment about any point that you like. Any point that you like. Okay. So because the moment will be same. The moment will be same. Okay. So as you know that if you have two different force in 3D, you want to find the resultant of moment. Okay, you have this formula. Oops, you have this formula. Okay, you have this formula. We have two different force. You want to calculate a moment about point O. Okay, about point O. Then you have this formula. The first one is for the force. Let's say I put it F1. Okay. The second F is F2. Okay. If you want to find a moment about point O. Okay. So at the end of the day, if you simplify the equation, okay, you simplify the equation like this. Okay. You know that RB is equal, RB minus RE, okay? So RB, where is this RB, okay? Minus RE, this one, you will get R. You will get R. So we know that this one, you substitute into the equation and finally you will only have a simple equation as a definition stated in the previous lecture. M, moment about a force, moment of force about a point O is equal to R cross F. Okay, R cross S. This is the simple equation that you will use to calculate a moment if you have a couple system. No need to have this one anymore. No need to have this one anymore. Okay, so you just only use the simple equation of moment there because it is a couple. It is a couple. Let's say the system not having couples, then you have to use this kind of method to find the moment. Okay, so observe that moment of couple is independent of point O. Yeah, independent as shown in the previous 2D couples. Okay, you can put any moment. Sorry, you can put you can calculate a moment about the point using any forces that you like because the force will be same. Okay, so this is the equivalent couples in 3D. So let's say you have two different plane, the top one and the bottom one. Okay, the bottom one. Okay, with force there P. Okay, P, and the below one is Q. Okay, different plane. You can assume as stated in the previous statement, you can assume the moment about both couples. Okay, the moment for the both couple will be same. Okay, let's say you want to find the moment here. Oops, here, moment here. Let's say I put moment 1 lah. let's say you get 100 Newton meter, and you want to find the moment here as well, moment 2, you will get the same answer. Okay, you will get the same answer. Okay, this one, because it is in the same it is in the same parallel. I mean the parallel plane, actually the parallel plane. Okay, like we learned just now. Okay, this one, both couples are on the same or parallel planes. Okay, so two couples of P and Q and in the 3D model, in the 3D system just now, is same. Yeah? If both couples on the same or parallel planes. So this is the meaning of the fourth statement. Parallel plane. This is the first plane. This is the second plane. Plane 1, plane 2. So plane 1 and plane 2 is parallel. So if you want to calculate a moment for plane 1, okay, you will get the same answer for plane 2 as well. Okay, this is the thing that you have to aware about a moment couples for the two different plane. Okay, same goes to 2D. We do have addition and subtraction of couple for the 3D. Okay, let's say you have two different moment, M1 and M2. You can just add both of them. You can subtract both of them. Okay, like this one. Okay, and of course the moment 1 and 2 must be in term of IJK form. Okay, you can add both of them like this. You will get this one. Okay, and same goes to subtraction. Okay, you just minus both of them in a same component, X, Y, and Z component. Okay, as simple as that. Okay, before we proceed to the example, is there any question? Is there any question, guys? Any question?
No, doctor.
Can I proceed?
Doctor. Yes, doctor.
Okay, great, great. Okay, let's proceed. Okay, let's proceed to the next one, which is example 1. Okay, all right. Okay, all right. Okay, all right. So the question asking you about a moment. Okay, so you have to replace the two couples shown in the diagram with one equivalent couples. So meaning that you have to find the moment. Okay, you have to find one single moment, one single moment, one single moment. Okay, like this. Okay, like this. Equivalent couples. Okay, you have two different. This one for this case is actually the plane is parallel. The plane is parallel. Okay, the plane is parallel. If you want to find the equivalent couples, then you have to find the moment total lah. Okay, let's say MP plus MQ. So MP and MQ is equal. Okay, but this time around, example 1, the plane is not parallel at all. Okay, another one for the 18 Newton, the plane is on the X, the Z plane. Okay, this plane. Okay, so for the 34 Newton, the plane is like this. This is the plane. So you have different. You have two different plane for this example. Okay, so of course, this moment, let's say I put moment, in red color and green color will not be same. Will not be same. The moment will be different. The moment will be different. Okay. Okay, back to the question. You have to replace two couples. Okay, two couples. We do have two couples. The first one is the green one. I put it 1. The second one is the red color, which is M2. Okay, two couples. Okay, M1 and M2. Shown in diagram with one equivalent. You have to replace 1 and 2 into one equivalent couples, meaning that there is only one moment later on, one couples. One couples meaning one moment lah. So you have to find this one. Okay, you have to find the total moment lah, the simple word total moment. So total moment you have to do subtraction or addition. Okay, so in this case I add both of them, M1 plus M2. Okay, so the idea is like this. The idea is like this. So before we can get the total moment, you have to get a moment first for the individual plane. Okay, so let's say we start with the simple one, plane AB, sorry, plane ZX, which is this plane. Okay, this plane. And this plane having 18 Newton forces. Okay, so from here you have to calculate moment lah. Okay, how to calculate? Anyone? How to calculate? How to calculate? How to calculate? Calculate. Anyone? No, Saida. No, Shaida. Are you here with me? No, Shaida, ada ke tak? Tak ada ke? Saya cakap seorang-seorang No, no, Shaida, are you here with me? Najwa Afifah? Najwa Afifah? Rabiul Hasan?
Yes.
Okay, how to calculate moment for this plane?
First we have to find R and substitute, and it's 18 Newton with R. For R we have to find
Okay, so for the moment, which point that you want to take?
point O.
Okay, great. So I put it point O. So how about the R? If you calculate moment about point O, R from where to where?
O to S.
Okay, how much is that? R
0.30.
0 0.3. Okay, in which direction?
Anti-clockwise.
In which components?
X
0.3 in which component? Sorry.
X component.
So I lah, right?
Yes, yes, doctor.
All right. Okay, this is your R. So how about F? Which F you want to take?
OA.
OA. No, you cannot take that one because you are calculating moment about point O. So the point, this force is eliminating, will be eliminating. You will not use this one. Okay. Because you are taking moment at this point.
So we should take X.
Sorry?
Point X.
Sorry?
Point X. OX.
Not point X, this point lah, right?
Yes.
Okay, you will take this force. Okay. So, but this force is only a magnitude. So you have to transform it into X, Y, Z component, IJK form. So how? How? Mm? Mm-hmm. Mm. So what is the value of F for this 18 Newton in terms of IJK form? Okay, I ask another person. Sharifah Raihana. So what is the value of F in terms of IJK form? Sharifah Raihana, are you with me? Ish, janganlah senyap je.
Yes, doctor. Sorry. Hello?
Is it?
Yes.
Okay, can you tell me what is the value of F in terms of IJK form?
In terms of IJK,
How much? That one is very simple actually. No need to use.
negative 18K.
Ah, correct. Tengok jawapan kat chat
Huh?
Ada. Okay. So the answer is, sorry, negative 18K. Okay, correct. Okay, correct. So you have this one, these two. So substitute into the equation I. Okay, cross with F, negative 18K. Okay, you will get straight away, the moment 5.4, 0.3 times with 18 equal to 5.4, and then the direction should be J lah. Okay, J. Okay, it is cross product Newton meter. Okay, let's say I put it MO. Okay, this is your first moment. Okay, everyone, do you understand on how to get it?
Doktor,
Yeah.
macam mana nak tahu mana satu nak eliminate?
Okay, great question. I like this question. Bagus. Tanya. So, the siapa yang tanya ni? Intan eh? Okay, Intan asked me how we can eliminate one force. Okay. How we can determine which point that we want to take a moment. Okay, good question actually. So basically, you can take whatever point that you like. Let's say let's say here, for example, let's say here, for example, let's say here, for example, okay? Because the moment every single point here will be same. 5.4J will be same. You can take any point that you like, as I mentioned to you in the lesson, the previous slide. Okay, this one. Never mind, I can recap back. Okay, this one. The moment possible couple is independent. Okay, so it is independent. Okay, you can take any point that you like. For this case, you cannot take this one, 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 you cannot take this one. Because if you take this one, this point, the solution will be too long. Okay, so the easiest one is the point here, the first point here, or the second point here. Okay, the thing that I show you is I'm taking at this point. The thing that I show you, I'm taking this point lah, this point. So if I taking this point, these forces will not consider in our calculation, okay, because there is no D, okay, D should be perpendicular. D should be perpendicular. So from this one, the force is like this, meaning that there is no D from the line of action to the point, which is the D is equal to 0. Okay, no D. So that's why we can eliminate this force. Eliminate. So we only consider this force in our calculation. Okay, all right. So if I choose this first point, if I choose the second point, let me erase this one. Okay, if I choose the second point here, point number 2, okay, you can calculate moment as well. Okay, so let's say this moment I put it point A, B, C, D, ada D. I point E lah. Okay, point E. Okay, point E. Okay, if you choose this point, you will not considering this force in your calculation. You only have to use this force in your calculation, and the answer will be same as this one. If you don't trust me, we can try now. Okay, so if you calculate moment about this point, point E, and E, oops, R cross F. Okay, so F is only this one in the direction of Z should be positive. F equal to positive 18 K. Okay, Newton lah, of course. Okay, and the direction should be from E to O lah. The direction, I mean the direction of R. This is R. Okay, REO. Okay, so REO, this one should be EO. Okay, this one should be point of E2. So REO should be from E to O. It should be positive, sorry, negative 0.3 I. I. Okay, so you substitute those F and R into the equation here. Okay, so you will get the same answer. Moment 0.3 I cross with F 18 K. Okay, so you will get answer, the same answer, positive 5.4 G Newton meter. Okay. Okay. So the answer will be similar, whatever point that you take, whichever point that you take, this answer and this answer will be same. Okay. Okay, Intan. Did I answering your question?
Yes, Doctor. Thank you.
Okay. So you have to recap back the moment about point for the 3D. Okay. And the couple is only the application of moment. Couple is only application of moment. Okay. So you get a 5.4 G for the first moment of this force. Okay, 18 Newton force. Okay. Okay, not only that, since we have to find the equivalent couple, which is M. So M1 plus M2 lah. So M1 just now we get it 5.4 G. Okay, 5.4 G. G, right? Okay, G. Okay, so moment number 2 is this plane, for this plane. For this plane. And this plane having a force of 34 Newton. This one. From D to this point. Okay, from this point to this one. Okay, so 34, 34. Same goes to this plane, you have to utilize this equation. Okay, you have to find a moment. Okay, so how to find a moment? Let me pick one name. Siapa nak ambil ni eh? Chai Yi Wei. Are you still with me? Chai Yi Wei. Are you still with me?
Doctor,
Yeah.
writing in the chat.
Sorry.
He wrote in the chat, Chai Yi. Using the chat. He said yes in the chat.
Oh, in the chat. Okay, okay. Yes, Chai Wei. Can you tell me on how to find the moment? Of course, you have to get the R and F. Okay, can you tell everyone? This one is a bit tricky lah. Chai Yi. So everyone, please prepare the answer. I will ask you also. Okay, Chai Wei Yi. Which point that you want to calculate moment? Okay. D. Okay. You want to calculate moment about point D. Okay. You have to get R and F. So what is R? From where to where? Chai? Okay lah, I ask another person lah. Okay, thank you, Chai. How about Alia, are you with me? Alia, ada orang ke? Alia? Oh, Alia. Come on lah, respon sikit. Alia? Tak ada ke ni? Okay, my question. How to find R? What is the value of R? Chai said that she want to calculate a moment about point D. Okay, here. Okay, here. So we have to determine R. So R from where to where? Okay, maybe someone can help Alia to give answer.
Doctor, it consists of J component, I component, and J component. Sorry, I and K component.
Is it
So 0.3 I and 0.17 K for R.
okay? The answer is wrong.
Doctor,
Yeah.
is it from point D to C?
Yes, correct. Okay, let me show you some idea lah on how to get the moment, on how to understand the solution. So if you are taking a moment about point D, okay, point D here, okay. So the point D having this force, okay, having this point force. So you can eliminate this one. You will not consider this force in your calculation because there is no D. D equal to 0. Okay. The only thing that you will use is this point, this force. Okay. So a moment in 3D, okay, a moment about point D, you have to consider this force, make sure that it should be in terms of IJK form, okay, and then the distance of R should be from D to C lah, okay, the D to C, okay, the simple one, okay. I think Osam also get the correct answer, which is Osam take this R. Is it Osam?
Yes, Doctor, this one.
This one is also can. This one is also can, but you will have two components. Okay, you will have two components. But the simple one is R1. You only have one component, which is R here. Okay, R1 is from D to C, which is this value 0.17. The position is ZK. Okay, in positive direction. Okay, Sin Biki, thank you so very much for the answer. So you will get this R. You can also use this R, but it will have two components. Okay, you will have two components. Okay, you have to use the simple one. You have to use the simple one. Okay, R is done. How about the force? How about the force? Anyone? How about the force?
Two components, right? I and K. Because it's parallel to the plane. It's on a plane. So there's two components.
No, there is three components actually. Yeah, Tan Wee Kang. Coordinate method. Yeah. So if you still remember in 3D, resultant or equivalent system in 3D, okay, there are three methods that you can calculate a force, okay, in 3D. The first one is the first angle method, second angle method, and also the third one is the coordinate method. So for this case, we can use only the coordinate method. Okay. from point C to point E. Just now I put point E here. Okay, point E. Okay, you have to use coordinate method. So meaning that you have to identify dx, dy, and dz. Okay, you have to use this formula. Oops. The force should be F lambda. Okay. The lambda. Okay, the lambda is the direction. Dx over d, okay, I plus dy over dj plus dz over d k. Okay, so you have to identify dx, dy, dz, and of course d. Okay, from this case, what is dx?
0.15.
0.15.
15.
Negative, positive?
Positive. Because it's in the right.
Correct. 0.15. Okay, how about dy?
dy positive also.
Wrong. Dy should be negative. How much dy? Yes, correct. Negative 0.08. Okay, how about dz? Yes, correct. Vilina, negative 0.17. So how about d? Can someone calculate for me d?
0.24.
0.24. Okay, you substitute all those information in this formula. Okay, f is 34. You will get the answer in terms of IJK form, and the answer of force in terms of IJK form is 21.2 I. Please check. Minus 11.3 J and 24 minus 24 K Newton. Okay, right. Okay, right. Okay, please check the answer. Yeah. So once you have R and F, okay, F, substitute into the equation, okay, you will get MD straightforward. Okay, you will get MD using the cross product, you will get 1.921 I plus 3.644, for example. I'm use 3 decimal places. Let's say in this example, we use 3 decimal places, for example. You can use 2 decimal places. As I mentioned to you, you can use 2 decimal places. Okay. All right. So you have this one. You have the M1. Okay. You have the M1, 5.4G. And then you have MD, M2 lah. Okay. And then you have to substitute. Not substitute. You have to add both of them you will get the final answer. You will get the final answer. Okay, you will get the final answer. Let me show the final answer. This one. Okay, this one. The final answer is the addition of M1 and M2. So you add M1 and M2, you will get the total M. Yeah, total M. Okay. So this is the thing that you have to know. If the question asking you to find one equivalent couple. Okay. So meaning that the simple word is that you have to find moment lah, the total moment. Okay. Okay. Any question? Any question? Any question? No. Do you understand? If you don't understand, please ask. Do you understand? So far, okay, Dr. Wong Kin Tong. Okay, Wong Kin Tong. Should I call Wong or should I call Kin Tong? Okay, okay, Wong. All right. So if no question, let's proceed to the next one. Okay, before we end the class. Let me check. Okay, exercise. Maybe you can do it in your free time later on. Okay. So last slide before we end the class. Okay, last slide. It is about the forced couple system in 2D. Okay, the forced couple system. Okay, as I mentioned to you just now, you can transform the force into different position. Okay, you can convert the force into the different position. Okay, you can transfer the force into different direction and magnitude as well. Okay, if you have the what do you call it, couple. Okay, if you have the couple system, this is the force couple system 2D. Okay, you can move a force to a different location. Okay, let's say some cases you want to study about the prosthetic leg, for example. Okay, you don't want to put the force at O, you want to put the force at A, for example. But of course, the initial force is on O position. Is at the O position. Okay, but maybe you don't want to have the force at O. Okay, you can move this force at A using force couple system. Okay, so how to make it? You have to introduce couple first. Okay, the couple should be like this lah. Okay, the couple should be like this. Let me draw. Okay, so in order to make a movement, okay, of the force, you have to use couple. Okay, so couple like this. This one is couple lah. Both. You introduce couple. But once you have introduced this force, okay, this force, okay, you cannot simply introduce force like that to have a couple. You have to eliminate this one as well, because the original system don't have this force. Yeah? The original system don't have this force. So to make sure that we follow the original system, okay, we have to introduce another force like this. Okay, because if you still remember reaction and action, okay, reaction and action. So if we have this force and this force, okay, one of them is action, one of them is reaction, then we can eliminate those forces, okay, those forces to become the original system like this. Okay, to become original system like this. And the idea is that, okay, the idea is that you have to introduce a couple like this lah. This one, this couple, okay. Okay, this couple. As I mentioned to you, we cannot simplify, introduce this couple, this force, because the original system don't have this force. Okay, so in order to make an equilibrium, in order to make a static, okay, in order to make a original figure, original system, we have to use this additional force as well, reaction and action. Okay, that's why we do have this one. Okay, this one is couple. This one is couple. Okay. All right. So if you can see this statement, apply two forces, cancel each other at point A. Yes, point A here. Two forces. Okay. Apply two forces at point A. So this one can cancel each other. But because we want to have a couple, then we just simply put like that. Okay. And then this next step, okay, this couple have the perpendicular distance. You can get a moment later on. You can get a moment. Okay. So in the end of the day, if you use couple, you will get a moment like this. And also the additional force at A. Okay. You calculate this. Oops. You calculate the couples, which is moment. Okay. For both forces. Okay. You will get a moment. A moment here. Okay. A moment here. Okay. So this is the thing that we can move a force from one point to another point. Okay. And of course, and of course, the original, the original one, okay, and the final one is same. Is same. Will be same. Will be same in terms of the system lah. In terms of the system, we can just use this force couple system to move the force from O to F point. Okay. All right. Do you get? Do you get? Guys, do you get the idea?
So, doctor, does the two forces have to be the same magnitude as the original one?
Yeah, it should be in same magnitude.
Okay, thank you, doctor.
It should be same magnitude. Okay. Any more question? Any more question? Alana, Elise, Mariam, do you understand? Okay, if no question, so I'll leave it to you to do this exercise one first. Okay. Later on, we will discuss the solution in the next class on Wednesday. Okay. Also, exercise 2. Okay. I'll leave it to you to do the exercise first. Okay. And then we will discuss the solution in the next class. Are you okay with that? Guys, are you okay with that?
Okay, doctor.
Yes, doctor. Sure, doctor.
Okay.
Okay.
So do it first, exercise and exercise 1, exercise 2. Okay. Do it first, then we will discuss the solution in the next class, on Wednesday. Okay. All right. So I think that's all for today. Thank you so very much. Okay. See you next class.
Thank you, doctor.
Thank you, doctor.
Okay.
Thank you, doctor.